Okay, number 3 of section 1.7. Let's read the instructions. Determine if the columns of the matrix form a linearly independent set. Okay. Well, what does that mean? It means, does there exist a set of numbers x1, x2, x3, x4 that will satisfy this equation other than the trivial solution of 0, 0, 0, 0? So remember, if they are linearly independent, it means if this is true, all these x's have to be 0. That's what linear independence means. But they are linearly dependent if there exists at least one non-zero coefficient in this equation. Because we already know that if they're all 0, it's true. But if you can find one where at least one of them is not 0, then they are linearly dependent. Okay, so we really just have to solve a system of equations, and here is the augmented matrix for the system. Notice, by the way, the system is homogeneous because the constants on the right-hand side are all going to be 0. So certainly the trivial solution exists, but that always exists. We want to find a non-trivial solution. So this kind of reminds me of something we did in the last section. It's really enough to put this thing in just echelon form to determine if there are non-trivial solutions. If there are non-trivial solutions, then this thing is linearly dependent, this collection of column vectors. So let's just concentrate on putting this thing in echelon form, which should take less effort. So I'm going to say -2 times the first row plus the second row. So -6 plus 7, 6 minus 4, -12 plus 6. And we'll go ahead and fix the last one too. -3 times the first row plus the third row. So -9 plus 11, 9 minus 2. Let's see, -18 minus 3, I think. And the 0 is not going to change. Okay, that looks good. Now, let's try to make this a 0, because we're just trying to put this thing in echelon form. So I'll leave the first 2 rows the way they are. But I'm going to multiply the second row by -2 and add it to the third row. -2 times 2 is -4 plus 7 is 3. -2 times that is 12. Minus 21, I think, is -9. Okay, so it looks like this thing has 3 pivot rows, because I was able to get a non-zero entry for the first non-zero element in each row, and the first non-zero entry in each row is immediately to the right of the first non-zero entry of the row right above it. So it looks like we have well, it looks like we have 3 basic variables, because we have 3 pivot columns. All right, but notice we actually have 4 variables here, so it looks like x4 is a free variable. But our basic variables are just x1, x2, x3, but it looks like x4 is free. Because this last column, I can never, I don't want to change this thing into a 1. It's just going to stay 0. So it looks like x4 is the only free variable, but that means this has non-trivial solutions. So these are linearly dependent. All right.